We will get there. You had to stay up all night. Oh, I'm sorry. That sounds exhausting. Oh, thanks for asking how I am. I'm super annoyed with my internet right now, personally, because the last 2 days it just keeps spinning and spinning. It's not good. Yes, we will get there, Justin. I think this is just a slower process than I want it to be. I'm not patient either. So let's see if we can't. Let's do this diet. Oh no, I don't want to do this diagram. I don't know. Maybe this diagram will help you. Okay. And then we'll go back to the video since you're asking about it. And then we will come back to this. Okay. So this is how this is a diagram that I made. Okay. So these black lines are the DNA strands. All right. This spigot up here represents the promoter, right? Because this is the water source. And this promoter is giving it a direction to come. So it's saying, hey, come this way. We want some water over here. All right. The next part would be the operator. So the actual operator is the spigot that opens where the water can come out and say, water, come here. This is where I want you. All right. And then our proteins are expressed. Right. So then proteins are expressed. So there's a promoter that says, like, that has a flag that says it's this way. We want you this way. The operator is actually the source of where it starts being coming to fruition. I wish you guys could see me flailing my arms around right now. My TV is also run by my internet, and it will not turn on because my internet is so slow, which is why you are not seeing my crazy arm motions right now. All right, anyway, so this is where it actually happens, and then our protein is expressed. Now, when we have the repressor protein, it kind of acts like a cap on the spigot. That we say, water, we want you to come this way. This is where you would normally come out. But because there's a repressor protein that binds to that operator, it's like a stopper. Does that make sense? I don't know. Sometimes I don't like all of the biology drawings, so I have to like make my own. Did that help anybody else? So again, this is our DNA. It's a piece of our DNA. And these are different codes that say there's a promoter piece that says, I would like to make a protein. And the operator is what says, this is what we want you to make. It's right here. And then there's a code that follows it that codes for this protein. And usually, like when the spigot is turned on, it can just be promoted. There's the code, it's read, and the protein is produced. But then when this mean repressor protein, the villain, is around, right? It stops it. Okay, sorry, Aria. I see your question. Okay, I hope that. But the promoter, operator, and DNA strand. So this is all part of your DNA that is making the proteins that your body needs for daily chores. Does that make sense? Daily chores. I love that. Daily chores is what it is, right? Because think about your daily chores. What are some of your daily chores? What are some of the things like, yeah, you need to make your bed, you need to do your dishes. You need to do what else? Vacuum. Good, Vincent. You need to dust. My child is allergic to dust, so I have to do dust. Oh, laundry. Speaking my language. All right. What happens if you don't do the laundry or don't clean your dishes or you don't sweep your floor or you don't take out your garbage? Oh, yes, Jenna, I'm with you on the kitty litter, man. It piles up. You're in trouble. You have a mess, right? Because listen, you can go through your dishes and just keep going and going and going and stacking stuff up in your sink. Same thing when you do your laundry. Like you can just like keep throwing it in your hamper. But like what eventually happens? You've got big old piles and you run out of underwear. You run out of dishes, right? Your floor gets nasty. Like if listen, I have 2 toddlers. If you look at my floor, I guess Mila's not a toddler, but if you look at my floor right now, I didn't get to sleep it last night because I was doing all kinds of stuff before bed. But like, I need one of those. I have a robot vacuum, the little ones that run around your house. It is dead. It needs a new battery, but like, I've got to get that fixed because I'm looking around and I see like sprinkles, beads, all kinds of weird things that my kids get into. All right. All right. Sorry. I went on a rampage about chores. But what happens is your cell is the same way. There's different things that your cell needs each day. What if you want lunch today? What are you going to have to do? What are you going to have to do to get your lunch? Tell your mom, oh, I want a mom again. I mean, I have a mom. She just doesn't live in my house. You're going to have to make it, right? So, to make it, you're going to have to at least get one dish dirty. You might have to, I don't know, maybe you need to pull out a skillet and warm up some meat, or maybe you're going to use the oven, or you're going to pull out some ingredients, right? You're going to make some dishes. You're going to have to, like, you're going to make a mess to make what you need. You need energy, right? Your body needs energy. And in order to get the energy that you need from your lunch, then you got to do the chores, right? You've got to make the protein. Perfect, Dustin, right? You always have to be doing something to get what you need. And that's not just something we do as beings, but that's something our cells are constantly doing too, right? They're constantly having to make proteins to get things done in the cell to be alive, to be sustainable, to not have a messy house. And so for in order to do that, we're constantly making these proteins. Even digesting our food requires these processes of proteins to be made, right? It's crazy. So our body is constantly sending little mRNA messengers to and from that nucleus. I need a code for this. I need the recipe for how to make my lunch. I need a recipe for how do I wash colors? Do I need to use warm water, cold water? What cycle should I put it on if there's some stained clothes, right? There's instructions on how to do so many things in life, right? Like, am I gonna take my mop to my carpet? I'm gonna take a wet mop to my carpet. Is that a good idea? Thank you, Kaden. No, like I'm not gonna take a wet mop to my carpet, right? There's a certain way to clean my hard floor. There's a certain way to clean my carpet. Same thing with like my wood furniture. Like if I take a wet washcloth and wipe down my wet table, but leave that and I don't dry it, what's going to happen to my wood? It's going to start cracking and warping, right? Think about all the processes you have. I have a coffee maker. If I leave my coffee maker on, like it'll burn up. Like I've got to make my coffee, but then I've got to stop it. There are instructions that we've learned from our brain, from our parents, from life, right? Yeah, that just like the mirrors. Does anybody have to wipe up the mirrors at your house? That was the pet peeve chore I got as like a a teenager. Okay, listen, my mom would be like, "This is how you wipe down the mirrors to not get streaks." I don't know. I still like for today feel like I still try really hard to not get streaks on my mirrors. But like she would use a certain chemical and there's a certain way that you wipe the mirror so it doesn't leave streaks. You can't use this kind of cloth. You have to use the other kind of cloth. What some people say you use vinegar now and that doesn't leave. I don't know. All right. But there's ways to do everything. There's directions in how to do all kinds of chores in your house. And that is just like the cell. And in order to get how to do the chore or to remember, there's not a mom, right? Our mom or the housekeeper of our homes that we live in are kind of like our DNA. They give us the instructional thing. Yes, no, I'm so glad you're taking notes. So, promoter, operator, and DNA strand make proteins in the cell. The promoter and the operator, yep, they tell the code where the code is, where to start the code. So the promoter is going to be kind of like, have you ever seen like when you pull up on the highway or on the road and there's some construction going on? First of all, there's like a sign out front and or like, so this would be like the sign that says like the construction ahead, right? The promoter is indicating this is where the code is. And then near the site, sometimes there's the little guy with the flag, right? That's either, or the sign that says stop or drive slowly. That would kind of be like where the operator is. And then following the operator is actually more of the exact amino acid chain or code, if that makes sense. So if you're making like construction signs, promoter would be like construction zone ahead. And the operator would be like, here's where the zone is. And then there would be the code, because then you usually see the trucks. So this would be like the trucks and the little painter. Maybe they're painting the road, the lines on the road, or filling the asphalt. That is going to represent those little pieces that are transcribed right there. So but when a repressor protein is around, absolutely. When the repressor protein is around, proteins can't be made, right? So sometimes you come to a construction site and you see those things. Like you'll see construction site ahead, and then you'll get there and they're not actually working. There might just be a sign that says drive through or drive slowly. Yep. Okay, sorry. Now I'm trying to follow track. Hopefully that is making sense. I'm trying to. Does that make sense to everybody? It's all right, Mia. My internet's being weird too. Okay, everyone's saying that helps. So, yeah, so like I love all these sciencey diagrams. They're good and all because those are things that we're going to see. But sometimes to understand what in the world these things are doing, Mrs. Rittenhouse needs her version. And this is my version. All right. The spigot is my version. You could make this the construction site. You can make this the list of chores, right? How nice would it be that if you like wake up and there's a chore list on your bed, and then on the chore list it says there are no chores today? That's awesome. That's a great repressor protein. Or if it says have fun. So Dustin, this is going to be in your DNA, right? So lactose, in the specific example of the lactose, this is going to be a code in your DNA that is then transferred to your intestine. Yes. So it'll be an intestinal cell, I guess. If that's what you're saying. It's an intestinal cell in the DNA of your intestinal cell. You guys are awesome. Okay, so let's watch this. Let's watch this where we left off yesterday. Because I know we all did every and watching going to not going to hurt anybody because this is just a complicated process. So let me find here where we ended up. Where were we yesterday? Oh, this is might not be the right one. Hold on. Let me. I guess I can do this. Can pull it up in this window. Um, Okay, I think it's right here that we started. So let me do this for a minute, and then I will share my screen. Yes, try refreshing, Kaden, see if that helps. All right, let me share my screen with you. Let's listen to the good old amoeba sisters. Start screen share. Let's share from the classroom. This is in your classroom too. So I'm going to open it up.
Using for RNA polymerase without somewhere to bind. If you watched our DNA replication video, you learned about DNA polymerase and how it had to have a primer to know where to start. Well, RNA polymerase needs a promoter. A promoter is a sequence of DNA where the RNA polymerase can bind.
Okay? Can I stay right here?
So you would think, okay, you got your RNA polymerase, you attach it to a promoter, and boom, you make your mRNA, which eventually will be used to make a protein. But there's this other sequence of DNA called an operator. The operator is a part of the DNA where something called a repressor can bind. The repressor, if bound to the operator, blocks RNA polymerase, and poor RNA polymerase cannot move forward and no mRNA can be made, therefore no proteins. So let's take a look at our setup here. This is an example called a lac operon. Notice there's a promoter region of the DNA, the operator region of the DNA, and there are 3 genes here that code for enzymes that help in the process of breaking down lactose. Lactose is a sugar. If lactose sugar is around, bacteria want these enzymes to be made so that they can use them to break down the lactose sugar. Then they can metabolize it. Fed bacteria are happy bacteria. Here's the repressor. There's actually a gene here that codes for producing the repressor. See this gene that we call I? It has its own promoter. Well, this gene codes for the production of the repressor. So why do we need this repressor? Well, it's wasteful to make things that you don't need. If there's no lactose, it wouldn't make sense to start making enzymes that work together to break down lactose. It would be a waste. The enzymes would just sit there. So if lactose is not present, then the repressor binds to the operator, and this blocks RNA polymerase. So mRNA cannot be made, and therefore the proteins, the enzymes in this case, cannot be made. But if lactose is around in the environment, something pretty cool happens. The lactose, remember that's the sugar, binds to the repressor. This changes the repressor's conformation. Try as it might, the repressor cannot bind to the operator. RNA polymerase finds its promoter, binds, and transcribes to make the mRNA from the genes on the operon. That mRNA will be used to make enzymes to break down the lactose sugar. And bacteria like to eat, so that makes them pretty happy. We have to say that we think it's pretty impressive to think about all the gene regulation that occurs in cells. And if you find it fascinating, know that there are careers that focus on gene regulation and understanding how genes can be turned on and turned off. Because by doing that, we can gain a better understanding of a variety of diseases that have gene influences in the human body. Well, that's it for the Amoeba Sisters, and we remind you to stay curious.
All right. Stop sharing. And then come back to me my PowerPoint. All right. I don't know who that is, but she's proud of me.
She's my physical science teacher I had last year, and I believe some other people had her last year.
Oh,
she used to show these videos like all the time. It's just that's why I love the Amoeba Sisters.
They are good. They just explain things really well. They explain them like if I could be a viral video maker like that, I feel like I would be them. Because I feel like I would like to make videos like that that make things make sense in the most unsciency way possible, but still yet sciencey. Right? Because did that help anybody? Do you feel like that was beneficial? I don't feel like that was beneficial. Yes. Oh, I love it. Okay. We're doing it. All right. So we make those things. We make those proteins. In this case, we make that so that our bodies so the bacteria in our intestines can digest things. All right. So eukaryotic gene expression. This is us. So we're shifting. Right? This is eukaryotic cells. And we know there are cells because EU not only means what? It means what? Does anyone remember? Sorry, I'm talking in cycles. They're the types of cell you have. You don't understand why there needs to be a repressor. Well, there needs to be a repressor to turn things off because think about it, Ireland, if your washing machine every hour just kept doing a load of like starting off. You know what I mean? Like whether you put laundry in it or not, it just kept going. So it'll be a process in the cell. A process in the cell that does turn off. Yes. So like think about it about like the light switches in your room. Like, do you need every light in your house on all the time? No, like I'm looking around and there are some lights in my house that don't need to be on right now. Like I can see the bathroom light and the laundry room light down the hallway that don't need to be on right now. Yeah, it's just wasting electricity. So when does it happen? Kind of just like when you leave the room, right? So when you're in the laundry room, you turn on the light, you do the laundry, and then when you're not doing the laundry, you don't need to do a load of laundry. You're not in the laundry room right now. Like at night, maybe, when you're not filling your body with food, your stomach doesn't need to be like continually making more stomach acid or digestive enzymes. So it can be like, all right, we can turn that off for a minute, right? And that's actually what's so beneficial about sleep. Is that all your processes that go on in your cells during the day when you're using them on the inside of your body, they get to rest. And then your sleep is actually like a healing time for your body. So other things turn off when you sleep, and then certain repair processes turn on. Or you start like remaking the things that you need in your intestines for digestion the next day. Does that kind of make sense? So like if you're not constantly digesting food, you're going to only need that like lactose enzyme in your intestines to be turned on when you're going through digestion. And then it can be turned off, especially for a period. I'm totally into like health nutrition stuff and the food science. Oh yeah, there's tons of these little things that turn off and on all the time in your cells. So like digestive rest happens at night. I do something called intermittent fasting. So what I do is I eat all my food in a certain period of the day. Does that make sense? I eat all my food in like 6 or 8 hours. And I do that because then when I stop eating at a certain period of a day, I give my body 16 hours of digestive rest. And that allows my intestine to heal. It allows the bacteria to reculminate. All right, just like if you never turned your car off, and even when you weren't driving it, you left it on in like outside your house or in the garage, that would not be good. Does that make sense? Oh, good. Yeah. Like you wouldn't just want to leave your car on all the time. That would be really hard on it. It might survive for a while, but then it would probably, something would go bad. The whole car might not go bad, but something in the car might go bad that's going to cause you or it. Yes. Waste of energy. Perfect. And that's just like our bodies. Just like our bodies. We don't want to keep them running full time all the time. And so sometimes we need that. I called the repressor gene the villain. All right. Just like your mom or dad, or if you have like a bedtime or a curfew, like they seem mean, right? But they're put on there for good purpose. Right? Just like you have a bedtime or a curfew to keep your body safe, to get you rest, because without rest, you can't function well, right? Or you shouldn't go be out at a certain period of night, because guess what? Good things just don't happen that late at night, right? Nothing good happens after midnight. That's what my dad always said. Maybe not necessarily at your house, but still, I know that's hard with insomnia. Maybe try some melatonin. But you see what I'm saying? Those repressor proteins, I made them out to be the villain, but sometimes things that feel bad are actually still really good for us, if that makes sense. Right. So eukaryotic genes are cells with EU true nucleuses, are a little bit more complex. All right. So there are those little bacteria that are in our intestines. We all have bacteria in our intestines. They're good guys, not bad guys. They help us digest our food. All right. So our cells are a little bit different than those little bacteria cells. All right. They're more complex. All right. Eukaryotic genes are regulated by transcription factors. All right. We remember transcription, right? Transcription and translation. When we go get the RNA from the DNA and bring it to the different organelles of our cells. All right. Without the transcription factor, RNA polymerase can't begin. So instead of having that repressor, okay, like in our prokaryotic cells, animal cells or more complex eukaryotic cells, they actually have what they call a transcription factor in them, right? That will be the difference. So let's look here. Here is our eukaryotic cell. This again is a Mrs. Rittenhouse diagram. Transcription factors, all right? So this is a transcription factor protein. All right, it turns on the gene and allows transcription to occur. All right, the transcription factor is kind of like the glasses. It is the good thing, right? We need this transcription factor. It's like a person that can't read without glasses. Here's our newspaper. We cannot read the newspaper without our glasses. So when we have our transcription factor protein, it is the turn on, okay? It allows us to be able to read the DNA and for transcription and translation to occur and for us to create the proteins. Over here, the sad emoji, all right, transcription cannot happen because there is no transcription factor. He lost his glasses, all right? There's no glasses on this poor man, and he can't read without his glasses. Therefore, transcription, translation cannot happen, and we cannot make the proteins. It's a way of turning off the genes, right? It's like if you stayed up all night reading, but you could only read with your glasses, and your mom or someone at your house wanted you to go to bed and stop reading, maybe they would hide your glasses, right? So that you couldn't read. So this is in the eukaryotic cell. So we want to relate the water bottle diagram, and you're welcome to screenshot this. Water bottle diagram.
Mrs. Rittenhouse is just gone. Now she's back. She just got booted. If you guys in the recording are wondering.
That was weird. Can you hear me? Okay. All right, so this is our prokaryotic cell. Let's write prokaryotic cell. Karyotic cell. But this is our prokaryotic cell. And over here, our good old smiley face with the glasses, reading the DNA newspaper. Whoa, did it transfer? I don't like that. Neuro is being crazy. This is our eukaryotic cell. All right. Again, I would screenshot these things because for me, I can read and listen to videos and do all the things, but those are going to help me the most. All right. This is, can we not even look at that? Like this is the textbook version of this. Let's vote to skip the textbook version of that. It's the same thing. Like, look, here's our transcription factor. Because we have our transcription factor, we can read the code of the DNA. All right. Let's look here. How can we explain the differences? I think this was Justin's question, from infant to adult. What controls these changes? Like, why can't we just keep having these genes? All right. It's because different genes throughout as we age are turned off and turned on, right? Mainly because our body is growing and changing. And so the nonverbal cues that I was using as a baby, now my brain, if I need something, doesn't say goo goo gaga, right? I now turn off the sounds. Well, I still am pretty soundy, but I turn off those and turn them on. Yep, put it in your study guide. Your different genes turn off and on as we age, as our life cycle goes. Oh, we're getting so close. So let's do this. Let's go to these questions because these questions are your quiz. And I said I wasn't going to grade your quiz yesterday, and I made a liar out of myself, and I really didn't mean to. I think I went in and put zeros for those of you who didn't have it done. And then I was like, I just was like in go mode yesterday. I worked from like 8 a.m. till 8 p.m. I don't know what was wrong with me. But I put in, yep. I put in zeros, and I apologize for that. You get them back. You can still take them. They are not permanent zeros. And I just want to apologize for that out loud. So let's do this. And we can even pull up quizzes. So why is your keratin produced in your hair follicles but not in your stomach cells? So once our cells are born, wherever they're born, so if they're born on your head or in your hair, right? The DNA, the light switches for stomach acids are turned off. They're kind of like put into hibernation mode because we don't need them. All right, that's just kind of like why my brain doesn't remember how to do advanced algebra. Because I don't use all my advanced algebra anymore. So I forget some of those equation rules that maybe you guys are learning. Does that make sense? Because I don't use it anymore. So I forget it. That information was turned off in my brain. Same thing with the cells in your head. It's like, all right, what am I doing? Well, for some reason, I keep making keratin, and I haven't made stomach acid. It's because that information is turned off. All right. So some of my recipes I leave out, and I sometimes even put them on magnets to the fridge because I use them every week. And some of them are still in my cookbook in my cupboard stored away. I have all of my recipes, but my go-to recipes I've put on with magnets on my fridge because those are the ones that I'm using in this current phase of life. And that's exactly how our DNA is. Okay. No. So somebody asked if you go into a coma if everything is turned off. Not necessarily. A coma is just a slowed down state of our body that when something is going wrong and is going through trauma, it's just everything is kind of put on hold, but it's not put like in permanent storage in a cabinet. It's just a slowed down phase, if that makes sense. Yeah, you guys have so many good questions. All right, what happens to E. coli when lactose is not present? All right, when it's not present, the enzymes needed to break down lactose, are they continually produced? The genes that produce enzymes needed to break down lactose are not expressed. E. coli is not able to survive without lactose, or the genes required to produce lactose or are destroyed. I want you to think about that. Process. What do we think? What do you think? And this, I believe, is on your quiz. I'm going to give you a couple minutes. Think on it. What do you think? Nobody's voting? Oh, man. See, my thing is on delay. My thing is on major delay today. All right. So what happens is it's actually D. The genes required to produce the enzymes to break down lactose are destroyed. Or no, not destroyed, not expressed. Sorry. B.
Oh,
You're
yeah,
right.
you're
I'm
confused
sorry.
for a minute.
No, I'm sorry. I was looking at the wrong one. B. Okay, they are not expressed. When we don't have laundry, we're not running our washing machine. Number 2, when is gene expression blocked in the lac operon system? When is it when the repressor protein blocks the genes from making mRNA? When lactose binds to the repressor, RNA begins transcribing genes. The repressor protein destroys the genes to produce enzymes. Yes, it is A. All right. It is A. And last of all, what is the lac operon in E. coli a classic example of? Is it antibiotics blocking protein, gene expressions that lead to mutations, gene expression occurring by changing protein shape, or gene expression occurring at transcription?
Mommy.
1 second, baby. What do you think? Oh, I didn't give you the thing. I'm sorry. There we go. Yep. Gene expression occurring at transcription.
Mommy.
Nope, don't take biotech. Maybe what I'll do tomorrow is we'll take it during class so we don't feel behind. Okay. We'll take biotechnology tomorrow. Maybe we'll try to get caught up. We'll do everything to get caught up. But I feel like now we're late and whatever.
Yeah, I was
But-
just about to take it because it was said it was overdue today.
Nope, don't stress about it. I'll change the date on it too. But let's get caught up tomorrow. I feel good about taking 2 days to get this done, though. I feel like you guys have a better understanding. Give me a yes or no. Do you feel like we feel better about when the lac operon is turned off and on,
Mommy.
and what causes our changes from infant to adult?
Mommy, can I borrow this? Mom, can I borrow this?
Yes, you can borrow
Ren's just too cute.
that. She is.
Don't look at me. Don't look at me. Don't look at me. Don't look at me.
She's trying to put my clothes on. She wants to borrow my shirt. Starts young, you know?
She's trying to
Awesome.
be your mini. Oh, sorry. She's trying to be your mini me.
Yes, she is. Good. Everyone's feeling better. I feel better. Aria, how are you physically feeling better? Is your throat feeling better today? All of our sickos in the house. Oh, good. All right. I won't keep you late. I know I'm pretty sure I'm late. Yeah, I am late. But we were awesome today. We had a good talk. We learned a lot. I will see you tomorrow so you don't have to miss me for too much longer. Thanks for being here, guys. Bye.